Back in 1950, a brilliant physicist named Enrico Fermi was sitting at lunch with some colleagues at Los Alamos. They were talking about the possibility of intelligent life on other planets. Everyone agreed. It makes sense, right? The universe is huge. There are billions and billions of stars. Many of them probably have planets. Some of those planets probably have life. Some might even have intelligent civilizations. And then Fermi, who was a very practical thinker, asked a simple question that nobody could answer. Where is everybody? That's it. That's the whole paradox. And I want to explain to you why this question is so important, and then we're going to look at some possible answers. Because the real fun in science is not in having the answer. The fun is in asking the right question and then seeing what nature tells us. Let me start with the facts. First fact, the universe is old. It's about 14 billion years old. That's a long time. Second fact, the universe is very big. In our galaxy alone, just one galaxy among billions. There are maybe 200 to 400 billion stars, maybe more. Third fact, we know that planets are common. Modern telescopes show us that most stars have planets orbiting them. So, if planets are common and life developed here on Earth, then why shouldn't it develop on other planets? Why shouldn't it develop on lots of other planets? This is what we call the mediocrity principle. It's a funny name, but it means something important. Earth is not special. Earth is not unique. We are not particularly unusual. We're just one planet among billions. Our star is just one star among billions. So if the conditions that allowed life to develop here exist elsewhere, and we have every reason to believe they do, then life should exist elsewhere. Lots of it, probably. Now, Fermi was a mathematician. He was very good at estimating things, and he did some quick calculations. He figured, okay, if life can develop, and if some of that life becomes intelligent, and if some of that intelligent life develops technology and decides to explore the galaxy, how long would it take to colonize the whole galaxy? You might think that's a long time, but here's the thing. Even if a spaceship could only travel at 1% of the speed of light, which is incredibly slow compared to what's theoretically possible, it would still only take about 10 million years to visit every star in the galaxy. 10 million years sounds like a lot, but remember, the galaxy is 12 billion years old. So there's been plenty of time. There's been 1,000 times more time than would be needed. And Fermi realized something important. It only takes one civilization. Just one alien civilization that developed spaceflight, that wanted to explore, that wanted to colonize. It only takes one to spread across the galaxy. And if that could happen, it should have already happened, many times over, because the galaxy is old. Some stars are billions of years older than the sun. So if life could develop anywhere, it should have developed somewhere old, and that civilization should have spread by now. So the paradox is this. The math says the galaxy should be full of civilizations. The galaxy should be crowded with visitors. We should see signs of them. We should hear radio signals. We should see the results of their massive engineering projects. Dyson spheres harvesting the energy of stars. Spacecraft. Colonies. Evidence everywhere. But when we look out at the universe, what do we see? Silence. Nothing. Not a single confirmed signal. Not a single piece of evidence that anybody else is out there. Now, this bothered Fermi, and it bothers scientists today. So what's going on? Why is the universe silent when the math says it shouldn't be? There are some interesting possibilities. Let me think through some of them with you. The first possibility is that life is much rarer than we think. Maybe we got incredibly lucky on Earth. Maybe the conditions that allowed life to develop here are so specific, so particular, that they almost never happen anywhere else. This is sometimes called the rare Earth hypothesis. And you know what? That's not impossible. Think about what had to happen for us to be here. First, you need a star like our sun. But not just any star. It has to be stable enough to support planets for billions of years. Most stars in the galaxy are actually red dwarfs, smaller and less stable than our sun. Then you need a planet in the right place. Not too close to the star, not too far away. Then you need the right kind of atmosphere. Then you need water. Then you need the right chemical conditions for life to start. And then, and this is important, you need a long enough time without major catastrophes. A long enough time for simple life to become complex life. For complex life to become intelligent life. For intelligent life to develop technology. At each of these steps, there are requirements. Specific, difficult requirements. Maybe we just happen to satisfy all of them. Maybe Earth is like winning the lottery. Not impossible, but very unlikely. There's another thought here, and I want to be careful about this because it's a little depressing. But another possibility is that maybe once civilizations develop technology, they destroy themselves. It's not a pleasant thought, but think about it. We have technology. We have nuclear weapons. We have the ability to poison our own atmosphere. We could create dangerous artificial intelligence. A sufficiently advanced civilization might have even more ways to harm itself. In fact, let me make this more general. Let's say that there's a filter, a barrier, somewhere along the path from simple chemistry to a spacefaring civilization. Maybe life itself is incredibly rare. Maybe that's the filter. Or maybe life is common, but intelligent life is rare. Or maybe intelligent life is common, but the transition to spacefaring civilization is rare. Or maybe spacefaring civilizations destroy themselves before they spread across the galaxy. A scientist named Robin Hansen called this the Great Filter. And here's the interesting part. The Great Filter has to be somewhere. Something is stopping civilizations from filling up the galaxy. It has to be. Now, where is this filter? Is it behind us or ahead of us? This is important because it changes what we should expect about the future. If the Great Filter is behind us, that means the hard part is already done. That means it was very hard for life to start, or very hard for life to become intelligent. But once you clear that hurdle, once you become technological, once you learn to do science and build spaceships, then it's smooth sailing. In that case, we might be one of the first civilizations. We might go on to explore the galaxy. We might become those visitors that Fermi was wondering about. But if the Great Filter is ahead of us, well, that's more worrying. That means the hard part is coming. That means something we haven't thought of yet is going to stop us from spreading. Or maybe we'll destroy ourselves. Or maybe becoming spacefaring is harder than we think. I'm not trying to be pessimistic here. I'm just being honest about what the question really means. Let me mention another possibility. Maybe civilizations exist and they're spread all over the galaxy, but they're just not visiting us. Maybe they don't want to visit us. Maybe there's a rule against it. Some scientists have proposed something called the zoo hypothesis. The idea is that more advanced civilizations deliberately leave younger races alone, the way a biologist might study animals in a zoo without interfering with them. That way the younger civilizations can develop naturally. Now, that's an interesting idea, but I'm skeptical of it. Because even if there's a rule, even if most civilizations follow it, there's probably at least one that doesn't. There's probably one that's curious. There's probably one that doesn't care about rules. And that would be enough. That would be enough to contact us. Just one rule breaker. And if they're advanced enough, we'd see evidence of their rule breaking. Here's another angle that I find interesting. Maybe the problem isn't that civilizations don't exist or don't travel. Maybe the problem is that we're looking for the wrong things. Maybe we're looking for radio signals, but advanced civilizations don't use radio anymore. Maybe they use something we can't detect. Maybe they use the kinds of technology that look invisible to us because it's too far advanced. Or here's another thought. Maybe the distances are just too big. We think about traveling the galaxy, but the galaxy is truly vast. The nearest star to us is 4 light years away. Light years. That means that light from that star takes 4 years to reach us. A spaceship? At any speed we can currently imagine, it would take thousands of years. Maybe that's the real filter. Maybe the distances are so enormous that even if civilizations develop, they can't or won't try to reach each other. They can't overcome the simple physics of space. Actually, let me think about this one more carefully. If we sent a radio signal out into space right now, how far would it have reached? We've been transmitting radio signals for maybe 100 years. So our signals have reached maybe 100 light years out into space. That's a tiny, tiny sphere compared to the galaxy. The galaxy is 100,000 light years across. So the sphere of space that knows we're here is almost nothing. It's like a grain of sand on a beach. And if we think about listening, we're listening for radio signals from other civilizations. But radio is what we use. Maybe other civilizations don't use radio. Maybe they never developed radio. Maybe they went straight to something else. Or maybe if they did use radio, they only used it for a brief time, the way we might eventually stop using it if we develop better technology. So we're in this strange situation. The universe is old. The universe is big. The math says there should be lots of civilizations. But we see no sign of them. Not a single confirmed signal. Not a single piece of evidence. And you know what? That's okay. That's not a failure of science. That's a question, and questions are the beginning of science. Now, what I think is fascinating is that this simple question that a child can ask, this question tells us something important about our place in the universe. It tells us that we don't really understand something fundamental. We don't understand the conditions for life, or we don't understand the lifetime of civilizations, or we don't understand what advanced beings would do, or we don't understand what we should be looking for. The honest answer to where is everybody is we don't know. And that's good. That's the starting point for real investigation. Here's what we should be doing. We should be improving our telescopes. We should be looking more carefully. We should be trying to detect biosignatures, chemical signs that life is present on distant planets. We should be listening for radio signals, even though we might be listening in the wrong way. We should be searching for signs of massive engineering projects, Dyson spheres, for example, or other ways that advanced civilizations might be harvesting energy. And while we're doing that, we should be asking ourselves some hard questions. What does it really take for intelligent life to develop? How long do civilizations last? What would a truly advanced civilization do? Would they hide? Would they reach out? Would they expand across space? These are questions about the nature of life, the nature of intelligence, the nature of technology, and the nature of civilization itself. Big questions. Deep questions. Let me tell you something. I don't know the answer to Fermi's question. Nobody does. Not yet. Maybe we never will. Maybe we'll develop the technology to detect other civilizations, and we'll find that we're alone, which would be a profound and meaningful answer. Or maybe we'll find signals and meet our cosmic neighbors, which would change everything about how we see ourselves and our place in the universe. But here's what I know. The question is worth asking. The question shows that we're thinking. We're looking. We're trying to understand the universe and our place in it. And that's what science is all about. So the next time you look up at the night sky, think about this. Those stars are far away, yes, but some of them probably have planets. And some of those planets might have life. And some of that life might be intelligent. But if it is, for some reason, they're not here. They're not visiting. They're not calling. And we don't know why. That's a mystery worth solving. That's a question worth thinking about. And that, to me, is what makes science wonderful. It's not about having all the answers. It's about understanding that there are questions bigger than ourselves, and then having the curiosity and the courage to try to answer them.